All right, 7.4, we are looking at two what we consider special right triangles that always follow a specific pattern. Now, this what's written in blue right here, this blue triangle, you don't have to memorize everything that's in blue because I'm going to give that to you, but we do have to know how to use all of that stuff. So essentially what it is it's a formula. Because these right triangles, if you have a 45, 45, 90, which is talking about the degrees of the angles. If you have one of those triangles, it will always follow this pattern where the two legs are the same length. Okay, why would they be the same length? Because it's isosceles. If you have two base angles, the 45s, the two sides would be the same. Okay, and then the hypotenuse is whatever those legs are with the square root of 2 on the end. Okay, so here's two rules on working from the legs to the hypotenuse or from the hypotenuse to the legs, because they're only going to give you one side and you have to fill in all the others. Okay, so let's try that. Here's 4 examples. Notice I've only given you one side, and we're just going to follow the pattern from up above, from that blue triangle. Okay, so we have a 45, 45, 90. If this is 3, which other one is 3? The one on the bottom. Okay, so we got a 3 there. What would we write on the hypotenuse? 3 square root 2. That is all. Okay, on the next one I gave you the hypotenuse of 6 square root 2, so how long are each of the legs? 6. Yep. This is the easiest form of these problems. They get a slight bit more difficult when we do the next two, so I'll show you what we do on those. Okay, but if you have a triangle like these first two, I'm literally just asking you to fill in the other two sides following the pattern up above. Okay, now the reason the next two are a little bit more tricky is because they don't, initially it doesn't look like they follow the pattern. Okay, because looking at this one, the hypotenuse is 9 instead of what you would typically see, which is a number with a square root of 2 on the end. Okay, but even on these ones back here, to go from the hypotenuse to here, what you're doing is you're taking this number right here, the 6 square root 2, and you're dividing by the square root of 2. Well, what happens to this? The two roots end up canceling out, which is where we get 6, which is our answer on the side there. Okay, so that's really what's happening with this pattern. So we're going to do that same thing to get from the hypotenuse to each of the legs. We're going to divide by the square root of 2. Okay, so we got 9 divided by the square root of 2. Now technically that's the answer that you would put on both sides, but with fractions, fractions are kind of finicky. Okay, for instance, you can't have 0 on the bottom of the fraction. You can't have square roots on the bottom of a fraction. There are multiple things where the denominator is saying, no, you can't have this here. Okay, square roots is one of them. So here's how we get rid of it. If you have a square root on the bottom, which you will on some of your problems, you're going to just multiply the top and the bottom by that square root. Okay, which is essentially multiplying the fraction by 1. Okay, well, let's simplify this. We just multiply straight across. So on the top, we have 9 root 2. Now let's think about what happens on the bottom. We have square root of 2 times square root of 2, which is really the square root of 4. What's the square root of 4? 2. Okay, so this right here is the same thing as this. This second answer here is just a much better answer. Okay, because it's written properly. So 9 square root of 2 over 2, 9 square root of 2 over 2 would go on both legs. Okay, that same pattern is going to be used every single time you divide by a square root. The next triangle we learn is also going to have a root in it, so it's going to also need that if you're dividing. Okay, on this last one here for a 45, 45, 90, how long is this vertical side on the left? Yep, it has to match the other leg. Okay, so this one's also 13 square root of 2. Okay, well, let's look at this first triangle again. If I have one of the legs, what did I do to find the hypotenuse? What did I write after it? Square root of 2, right? Okay, well, let's do that same thing. Right here, to go from the leg to the hypotenuse, we've got 13 root 2, which is our leg, root 2. Technically, again, this is the answer, but it's not written in the best form possible. Okay, so let's think about this. If we simplified this, what is that right there? Square root of 2 times square root of 2. Square root of 4, which is 2. So this is really 13 times 2. Well, we could make that even better. What would that be? 26. Okay, so this is really as tricky as it gets, are these two problems right here. But there are going to be problems on the test that are as easy as this, the first two. Okay, and again, you don't have to memorize this right here because I will give it to you on the test. You just have to know how to use it. Questions? Okay, let's try the other triangle. These are the only two triangles we're going to be using in special right triangles. This is called a 30, 60, 90 triangle, again, because of what the degrees are. Okay, so this pattern will always happen. I am going to refer to these sides, this one obviously being the hypotenuse. But then the legs, I am going to refer to them as the short and the long leg. Okay, because there's always going to be a short one and a long one on a 30, 60, 90. We're going to try a few more of these. One more than on the previous slide. Okay, so let's look at this. The first one, did they give us the short, the long, or the hypotenuse? Okay, so let's label that. It tends to help organize your thoughts. That way you can match it up with the pattern up above. Okay, so we started with the short side. So we're starting on this side where there's just an X. So if this is 4 right here, what would the hypotenuse be? 8. You would double it, right? 2 times 4. So we know there's an 8 right here. Using the formula up here, if the short one is 4, how long is the long leg? 4 square root 3. So they're always going to give you one side. We just have to fill in the other two using that pattern. Okay. We're going to skip this one. Let's jump over here to the third one. What one did they give us? We have the hypotenuse. Okay, so we're looking here on the pattern. So they gave us 6 for the hypotenuse. How long is the short leg? 3. Okay, so we'll put 3 over here. Okay, hypotenuse and short leg are always half or double, whichever direction you're going. Okay, well, if this is 3, how long is the long leg? 3 square root 3. Okay, let's look down. Let's do the middle one now, up here. Okay, which one do we have? The long. All right. So on the long leg, we normally have what? Square root of 3. Okay, when it's missing, we know we're going to have to do just a little bit of extra work when we're simplifying. So let's look at the picture up here. From the long leg to the short leg, what did we do? In this direction, we divide by the square root of 3. Okay, so I would write that on your picture. Okay, well, let's do that. From here to here, we need to take 8 and divide by the square root of 3. We can't have roots on the bottom, right? So thinking back to the last slide, how did we get rid of the root? So we're going to multiply by root what? 3. Okay, well, if we simplify that, what's on the top? 8 root 3 over 3. How do we get 3? Because it's really square root of 9 when you multiply them, right? Square root of 3 times square root of 3 is 9. Square root of 9 is 3. Okay, well that goes here. 8 root 3 over 3. Well, how do we go from the short to the hypotenuse? Multiply by 2, you're doubling it, right? So from the short, which is right here, the short, 8 root 3 over 3, if we double that, what is it? Good guess. The only thing that changes is that first number, because you're multiplying by 2 over 1. So the denominator won't change. And we can't multiply roots times numbers outside of roots. Okay, so that just doubles the 8. 16 root 3 over 3. All right, so let's look here. What side did they give us? Hypotenuse. Okay, which was the side with the 2x on it. So how do we go from here to the short leg? Yep, we cut it in half. So this would turn into what? 7 square root of 3. Okay. So this is now the short one. How do we go from the short to the long? You're going to put a square root of 3 on the end of whatever is here, right, on the short side? Okay, so let's do that. We got 7 root 3 root 3. Because we're going to multiply by root 3. So if we simplify this, it's really 7 times 7 times. Okay, this is really root 9, right? What's the square root of 9? 3. So this is really 7 times 3, which is 21. Okay, so we've got those 3 right there. All right, well, let's look at this last one. What do we have here? The short, the long, or the hypotenuse? Long. Okay, and if we look at our key up here, to go from the long to the short, what are we doing? Let's divide by the square root of 3. So to go from here to here, we're going to go 6 divided by the square root of 3. We can't have square roots in the bottom. So we multiply by root 3. We get what? It's 6 root 3. And on the bottom, we get 3 now. So no more square roots in the denominator, which is good. Okay. This one, we don't want to write 6 root 3 over 3 because we can actually make this look a little bit nicer. Right here, we have a 6 and a 3, right? Out front. So we could simplify that fraction. What's 6 over 3? 2. So this is really 2 root 3. Why couldn't we do that up here? 8 and 3 we can't simplify. That doesn't become any nicer or cleaner. Okay, well, how do we go from the short to the hypotenuse? What do we multiply by? 2. So if we double this, we got 4 root 3. Questions? I'll have these 2 triangles up on the whiteboard so that you can use them. I highly recommend writing them on your assignment as well at the top.